Okay. So, very quick overview. 12-volt battery out of a Nissan. It's about a 60 amp hour, which runs through this 555 timer circuit, which is activated by this 12-volt automotive relay. That relay is triggered by this door switch, typical house alarm door switch. I'm not going to go through details, it's quite confusing with all the wires. Okay, but basically on this wheel, you can hear it clicking away, is two magnets there and there. Okay, powerful neodymium magnets, those boys. There's only two of them. This is just a gear that I misordered, but I just put it on there for a bit of extra flywheel power. Alright, so it's 555 box, powers these two ignition coils in parallel. Okay, high voltage comes out. Now I've rewired this a bit, so the high voltage comes out through that yellow and green wire to here, which goes to that copper ring that's actually supported by two loop bolts. Okay, so it comes out of there, through there, into there, through that loop. That rod there, I've now made the ground. So that comes out, okay, through the two electromagnets running in parallel, comes back to ground, okay, that runs back to the coil. So the voltage goes through there, jumps to another rod in there, from that rod jumps to this rod, and comes to the magnets. Okay, this rod is now connected through two blocking diodes, which are here, two 9 kilovolt blocking diodes. They come to this 1000, can't see it there, there we go, 2100 volts, 1.3 microfarad microwave capacitor. Okay, that gets charged up by this inverter. It's a 350 watt inverter running off of 12 volts, two batteries basically connected in parallel, so not series, not good for this, in parallel, so that there's 12 volts coming here but enough current that this doesn't run short. That comes out through another diode bridge so that I get DC power. Okay, so that DC power there, it's ground, comes back to the common ground. Positive goes out through there and joins to that rod there. So what happens is high voltage comes out, jumps to that rod, gets kicked back by these diodes, and jumps to ground through this wire. When that jumps to ground, it sucks the voltage out of this capacitor with it, through here, and together they go to ground through here, and when it sucks this current out, it powers these two boys and you get motion. Now there's a thing called flyback, which is when you charge up a coil. Sorry, a little brain fart there in my thing. Charges up the coil, and then when you switch the power off, it tries to stay on, and the polarity actually flips, which then causes problems in the electronics world. So I studied that. So now what I've done is I use that flyback through these set of diodes to actually charge these batteries, and it does work. I'll show you in another video in detail, but it will charge these batteries. I've tested it. So here we go. Now check the power that comes out of this thing. Still needs some fine tuning, but if I put something on there, I'm putting a bit of pressure on there. It's not slowing down much. Now I can adjust the speed by adjusting the frequency here. So I turn that down. And it slows down, down. So it's pulsing slower. Now I turn it up. It's going much faster. If it goes too fast, it actually shorts out the inverter. She's got off the screech. Yeah, basically that charges up these batteries, which I'll show you in another video. Switch it off. And she slows down. Switch it on. And these electromagnets do get very hot, so you'll see I've got a makeshift heatsink on here. It's just two flat aluminium bars, because these little boys previously used to get very toasty. Actually holding the heat quite well now that I've put in this flyback sort of collection method.